Hi dear children, very good morning each and everyone. Dear children, in the previous class we learnt the direction ratios and direction cosines of a line joining two points. Dear children, today in this session we will be learning the equation of a line or straight line in a space. The children's equation of a straight line in a space can be uniquely determined if a point on a line and a parallel vector is given. A point on a line and a parallel vector is given, or 2 points on a line are given. Again, the equation of a straight line can be uniquely determined if, number 1, if a point on a line and a parallel vector is given. Number 2, if 2 points on a line are given. Okay, so we'll see one by one. First we'll see if a point on a line and the parallel vectors are given. Here, first method we have equation of a line passing through the given point and parallel to the given vector. So we need to derive the equation of a line. We need to derive the equation of a line in a space which is passing through a given point and parallel to given vector. Here we will be deriving the equations in both vector as well as Cartesian forms. First we will discuss the vector form. So here vector form. Here, let O be the fixed point. Let O be the fixed point. Let L be the line passing through the point A whose position vector is A bar, whose position vector is A bar. That is, let L be the line passing through the point whose position vector is A bar, whose position vector is A bar. That is here OA bar, that is OA bar is equal to A bar. Again, let P be any arbitrary point or any point on the line whose position vector is R bar, whose position vector is R bar. So that is, let P be any point on the line whose position vector is R bar. Then we have OP bar. So OP bar is equals to R bar. Similar, this line will be parallel to a given vector, parallel to the given vector B bar. Again here, by figure, we have AP bar is parallel to B bar. From the figure, we have AP bar is parallel to B bar. from figure, that is AP bar is parallel to B bar, parallel to B bar. We know that if one vector is parallel to any other vector, then we write this as, that is AP bar is equal to some constant times B bar. The two vectors are said to be parallel. In the previous chapter we learnt, if two vectors are said to be parallel, if one vector is equal to some scalar times other vector, so therefore AP bar is equals to lambda into B bar. Let this be what? Equation number 1. So now AP bar is equals to, express this AP bar in terms of its position vectors. Therefore AP bar is equal to OP bar minus OA bar, OA bar. Again that is equals to, what is OP bar? We have R bar, so that is R bar minus, what is OA bar? Here we have OA bar, so that is A bar. Okay, now substituting AP bar in equation 1. Okay, substitute AP bar in equation 1. Therefore we have AP bar, that is R bar minus A bar is equal to lambda into B bar, lambda into B bar. Now bring A bar to RHS. Therefore R bar is equal to A bar plus lambda into B bar, lambda into B bar. So this is the equation of a line passing through the point whose position vector is A bar and parallel to the vector B, parallel to the vector B. So this is the R bar is equal to A bar plus lambda into B bar is the vector equation of a line passing through the point whose position vector is A bar and parallel to the given vector, parallel to the given vector. Okay, so this is the vector form. Children, again let O be the fixed point, let L be the line passing through the point A whose position vector is A bar and parallel to the vector B, parallel to vector B, that is OA bar is equal to A bar. Next, let P be any arbitrary point on the line, whose position vector is R bar, that is OP bar is equals to R bar. So now from this figure, so AP bar is parallel to B bar, so therefore AP bar is parallel to B bar. So we know that whenever two vectors are said to be parallel to each other, then vector is equal to some scalar times other vector. Therefore AP bar is equal to lambda into B bar, where lambda is constant. Now so AP bar is equal to OP bar minus OA bar. But what is OP bar? We have R bar. What is OA bar? We have here A bar. Therefore R bar minus A bar. Now substituting the AP bar in the equation number 1, we have R bar minus A bar is equal to lambda into B bar. Bring the A bar to RHS. Therefore R bar is equal to A bar plus lambda into B bar, which is the vector equation of a line passing through a point whose position vector is A bar and parallel to vector B. Next we have a Cartesian form. Here let A of x1 comma y1 comma z1 be any point through through which the line pass through, to which the line pass through. Let p of x comma y comma z, p of x comma y comma z be any point on the line and b bar is equals to ai plus bj plus ck, ai plus bj plus ck, where a comma b comma c are direction ratios of the given parallel vectors. Therefore, so here we have oa bar that is equal to a bar that is equal to, we have that is x1i plus y1j plus z1k. Again OP bar is equals to r bar that is equals to, we have xi plus yj plus zk. Then we have b bar is equals to ai plus bj plus ck. So now we have the vector equation of a line passing through a point and parallel to given vector. Therefore, that is the vector equation. So we have r bar is equals to a bar plus lambda into b bar. We have the vector equation, that is r bar is equals to a bar plus lambda into b bar. Therefore, the vector equation r bar is equal to a bar plus lambda into b bar becomes substituting the values of r bar, a bar and b bar. So we have r bar. What is r bar? We have that is xi plus yj plus zk is equal to a bar. What is a bar here? We have x1i plus y1j plus z1k plus lambda of, we have b bar, that is ai plus bj plus ck. So now addition of two vectors had two vectors. Therefore again that is equal to, we have that is x1i plus lambda into a1 of I. Therefore that can be written as what? That is x1 plus lambda into a, that is lambda into a of I. The children's adding two vectors, that is x1i plus lambda into ai. So therefore that is x1 plus lambda into a of I. Similarly plus we have here y1 plus you have to multiply lambda to this. Therefore lambda into b of j. Again we have z1 plus plus multiply lambda to c. Therefore lambdas into c of k. Here, so here we have xi plus yj plus zk. Now compare two vectors. We have xi, here we have xi. So your y similar. Okay, so we know that whenever the two vectors are equal, then their corresponding component must be same. Two vectors are said to be equal if and only if their corresponding components are same. Therefore equating the corresponding component. So that is equating the corresponding components. So we have so here we have x, therefore that is x is equal to, here we have that is x1 plus lambda of a, comma, here we have component of j, that is y is equal to a component of j, we have that is y1 plus lambda into b. So component of a we have z plus is equal to, we have component of k, that is we have z1 plus lambda into c. Okay, simplification, bring x1 to LHS, therefore x minus x1 is equal to lambda into a, comma, y minus, bring y1 to LHS again, y minus y1 is equal to lambda into b, again, comma, z minus z1 is equal to lambda into c. Okay, again simplification, find lambda, therefore x minus x1 by a, comma, sorry, is equal to lambda, again y minus y1 divided by b is equals to lambda, comma, z minus z1 divided by c is equal to lambda. Here each term is equal to lambda, so therefore this can be written as, that is x minus x1 by a is equal to y minus y1 divided by b is equal to z minus z1 by c. So which is the Cartesian form of equation of a line passing through the point x1 y1 z1 and parallel to the vector whose direction ratios are a comma b comma c. Details again. So this is the equation of a line in the Cartesian form, which is passing through the point x1 y1 z1 and parallel to the vector whose direction ratios are a comma b comma c. Okay, again dear children, so in the Cartesian form, let a of x1 comma y1 comma z1 be any point through which the line pass through. Again let p of x comma y comma z be any point on the line, then b is equal to ai plus bj plus ck. So now this can be done as what, y a bar or a bar is equal to x1i plus y1j plus z1k, and op bar is equal to r bar, that is equal to xi plus yj plus zk, and b bar is equal to ai plus bj plus ck. Now so we have the vector equation, that is r bar is equal to a bar plus lambda into b bar. Now substituting these values in the vector equation, we have xi plus yj plus zk is equal to, here a value, that is a bar is equal to x1i plus y1j plus z1k, plus write the lambda as it is, write the value vector b bar. What is b bar? We have ai plus bj plus ck. Add these two vectors. Now so comparing corresponding components, here these two vectors are equal. We know that any two vectors are said to be equal if and only if their corresponding components are equal. So by equating the corresponding components, we have x is equal to x1 plus lambda into a, y is equal to y1 plus lambda into b, z is equal to z1 plus lambda into c. Equating this. So here this is the equation. Okay, dear children, you must remember equation of a straight line passing through a given point and parallel to given vector, both in vector form as well as Cartesian form. We have vector form, that is r bar is equals to a bar plus lambda into b bar. You should remember both. Okay, so this is what Cartesian form, and this is the vector form. Next, using this we have 3 points, that is Note number 1, this Cartesian equation is also called as symmetric form. Number 2, the equations x is equal to x1 plus lambda into a comma y is equals to y1 plus lambda into b comma z is equal to z1 plus lambda into c are known as parametric equations. Parametric equations. Next, number 3, we have if the equation of a line with direction cosines L comma m comma n is x minus x1 divided by L is equal to y minus y1 divided by m is equal to z minus z1 divided by n. That is the equation of a line with direction cosines L, M, N and passing to the point x1, y1, z1 is given by x minus x1 by L is equal to y minus y1 by m is equal to z minus z1 divided by n. You should remember this also. Second one, we have equation of a line passing through two given points. Earlier it was equation of a line passing through a point and parallel to given vector. Now we have equation of a line passing through two given points. So first we will discuss vector form. Here let O be the fixed point, that is let O be the fixed point. Let L be the line passing through 2 points A and B whose position vectors are A bar and B bar respectively. That is let L be the line, passing through the points A and B whose position vectors are A bar and B bar respectively. Therefore OA bar is equal to A bar and OB bar is equal to B bar. The next, let P be any point on the line again whose position vector is R bar. That is let P be any point on the line whose position vector is R bar. That is OP bar is equals to R bar. OP bar is equals to R bar. So now see here, AP bar is parallel to AB bar. AP bar is parallel to AB bar. That is from figure or all right here. From figure we have AP bar parallel to AB bar. From figure, AP bar is parallel to AB bar. AB bar, that implies, sir, AP bar is equal to lambda into AB bar. AB bar, we know that two vectors are said to be parallel if and only if one vector is some scalar times other vector. Therefore AP bar is equal to lambda into AB bar. Okay, so now let this be equation number 1. Again, express AP bar and AB bar in terms of its position vectors. So now AP bar is equal to OP bar minus OA bar. What is OP bar? We have R bar. What is OA bar? We have A bar. That is equals to R bar minus A bar. Similarly, again AB bar. So that is AB bar is equals to OB bar minus OA bar. Again, what is OB bar? B bar. What is OA bar? We have A bar. That is equals to B bar minus A bar. Now substituting AP bar and AB bar in one. Substitute that is AP bar and AB bar in equation 1. Therefore we have substituting values. What is AB bar? We have R bar minus A bar is equal to lambda of AB bar. What is AB bar? That is B bar minus A bar. B bar minus A bar. Again bring this A bar to RHS. Therefore R bar is equal to A bar plus lambda of B bar minus A bar. Okay, so this is the equation of a line in the Cartesian, in the vector form, which pass through the point A and B, whose position vectors are A bar and B bar. So this is the equation of a, that is a vector equation of a line passing through points whose position vectors are A bar and B bar. Again, let O be the fixed point, let L be the line passing through point A and B whose position vectors are A bar and B bar respectively. Then OA bar is equal to A bar, OB bar is equal to B bar. Let P be any point on the line whose position vector is R bar, that is OP bar is equal to R bar. Look the figure. Here from figure, AP bar is parallel to AB bar. They are overlapping. So therefore parallel to each other. So that is two vectors are said to be parallel if one vector is some scalar times other vector. Therefore AP bar is equal to lambda into AB bar. So expanding or expressing AP bar and AB bar in terms of its position vectors. That is AP bar is equal to OP bar minus OA bar, that is R bar minus A bar. AB bar is equal to OB bar minus OA bar, that is B bar minus A bar. Substituting AP bar and AB bar here, we have R bar minus A bar is equal to lambda of, that is B bar minus A bar, which is the vector equation of a line passing through 2 points whose position vectors are A bar and B bar. Next we have Cartesian form. Similar method. Here let A of x1, y1, z1 and B of x2, y2, z2 be any points on the line through which it pass through. Again let P of x1 comma y1 comma z1 be any point on the line. Therefore, that is OA bar is equal to A bar is equals to x1i plus y1j plus z1k. OB bar is equals to, that is B bar is equals to, we have x2i plus y2j plus z2k, and OP bar is equals to R bar is equals to, we have xi plus yj plus zk. So now what is the vector equation of line passing through 2 points? That is, we have R bar is equals to A bar plus lambda of B bar minus A bar, B bar minus A bar. So now the vector equation of a line passing through 2 points, R bar is equals to A bar plus lambda B bar minus A bar becomes, that is substituting the values of R bar, A bar and B bar minus A bar. So we have R bar. What is R bar here? That is we have xi plus yj plus zk is equal to A bar. We have A bar, that is x1i plus y1j plus z1k plus lambda of B bar minus A bar. B bar minus B bar. What is B bar minus A bar? So that is x2 minus x1. Distance I am just writing directly. That is B bar minus A bar. What is B bar? That is x2 minus x1. x2 minus x1 of I plus here y2 minus y1. That is y2 minus y1 of j plus z2 we have, that is z2 minus z1 of k. Now close the bracket. Okay, again try to bring this vector, that is x1i plus y1j plus z1k to LHS. We have therefore, that is xi plus yj plus zk minus of, okay, that is minus x1i minus y1j minus z1k is equal to, so now multiply lambda to each component. Therefore, that is x2 minus x1 of lambda into I, again plus multiply lambda to this. Therefore, y2 minus y1 of lambda into j, again plus multiply this to lambda to this term, that is z2 minus z1 of lambda into k, lambda into k. Here subtraction of two vectors. This one again don't get confusion with, so minus of this, that is minus becomes minus, multiply minus to each component, minus minus minus. Now subtraction of these two vectors. So we have, that is x minus x1 of I, again plus this minus this, that is y minus y1 of j is plus z minus z1 of k is equal to, so write this vector as it is. Therefore, that is x2 minus x1 of I plus y2 minus y1 of lambda into j, sorry, here write lambda into j plus, that is z2 minus z1 into lambda into k, lambda into k. Now compare this. So this is in terms of xi plus yj plus zk. So xi plus yj plus zk. Here the two vectors are equal. We know that if two vectors are equal, then their corresponding component must be same. Therefore, equating the corresponding components. Equating the corresponding components. What is the component of I here? We have, that is x minus x1, right, is equal to here what is the component of I here? That is we have x2 minus x1 of lambda again comma. Here next we have component of j, that is y minus y1 is equal to we have y2 minus y1 of lambda. Again we have component of k here, that is z minus z1 is equal to we have z2 minus z1 into lambda, that is z2 minus z1 of lambda. Okay, so now find the values of finding the values of lambda here. Okay, here we have that is x minus x1 by x2 minus x1 is equal to lambda. Similarly, y minus y1 divided by, bring this term to LHS, that is y2 minus y1 is equal to lambda. Again we have comma z minus z1 divided by z2 minus z1 is equal to lambda. So each term is equal to lambda, therefore equating all. Therefore x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equals to z minus z1 divided by z2 minus z1. So which is the equation of a line passing through 2 points x1 y1 z1 and x2 y2 z2 in Cartesian form. Details again. So let a of x1 x comma y comma z x1 comma y1 comma z1 be, and b of x2 comma y2 comma z2 be any 2 points on the line, and p of x comma y comma z be any point on the line. Therefore y bar is equal to a bar is equal to x1i plus y1j plus z1k. OB bar is equal to B bar is equal to x2i plus y2j plus z2k. Then OP bar is equal to R bar is equal to xi plus yj plus zk. Therefore, the vector equation of a line passing through 2 points, that is R bar is equal to A bar plus lambda of B bar minus A bar, becomes substituting the values of R bar, A bar, B bar minus A bar. R bar we have xi plus yj plus zk. Similarly, A bar we have x1i plus y1j plus z1k. Lambda of B bar minus A bar. So B bar minus A bar, that is x2 minus x1 of I plus y2 minus y1 of j plus z2 minus z1 of k. Now bring this x1i plus y1j plus z1k to the LHS. Therefore we have x1i plus y1j plus z1k minus x1i multiply minus x1i minus y1j minus z1k is equal to same term as it is written here, that is lambda, just multiplying lambda to this each term. So lambda, that is x2 minus x1 of lambda into I, y2 minus y1 of lambda into j, z2 minus z1 of lambda into k are written here. So now subtraction of these two vectors, that is x minus x1 of I, y minus y1 of j, z minus z1 of k, that is equal to right same as it is. So now compare this. So this is in the form of xi plus yj plus zk, xi plus yj plus zk. So here two vectors are equal, then it means their corresponding component must be same, equating the corresponding components. So we can write what equating the corresponding components. Here we have that is x minus x1 is equal to x2 minus x1 of lambda. Okay, again we have y minus y1 is equal to y2 minus y1 of lambda. Again z minus z1 is equal to z2 minus z1 of lambda. So find lambda, that is x minus x1 divided by x2 minus x1 is equal to lambda. Similarly, we have y minus y1 divided by y2 minus y1 is equal to lambda. then we have z minus z1 by z2 minus z1 is equal to lambda. So this every term is equals to lambda, therefore equating each term. Therefore x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1, which is the equation of a line in Cartesian form which pass through two points, that is x1 comma y1 comma z1 and x2 comma y2 comma z2. Okay, dear children, you must practice this two derivations well. Definitely they will be asking these derivations for 5-mark question in your annual examination. That is the question will be like this: derive the equation of a line passing through a point and parallel to given vector, or derive the equation of a line in a space passing through two given points. So practice these two derivations well. You have to write both Cartesian as well as vector form. Okay, so we'll see some problems based on this in the next class. Thank you.